Now we're going to deal with the case where it's 0 or 2 triangles. Again, you have to tuck away in your memory that the corresponding side less than the other side and in its acute angle would put you in this category of 0 or 2 triangles. And so what you're going to rely on is your calculator to let you know. So to get the ball rolling, I'm going to set up law of sines. Sine of 25 degrees over 1 equals sine of A over 2. I'm going to cross multiply remember 1 times sine of A is just sine of A. And then it is safe to do this, or you can show composing both sides, whatever you feel comfortable with. So when I go to my calculator, if I were to put this in my calculator and it tells me undefined, then I know it's 0 triangles. If I get an answer, then I know it's 2 triangles. So inverse sine of 2 times sine of 25 degrees. And what do you know? We have an answer. So what this is telling you is 57.7 degrees. That means this is 2 triangles since you got a value. So that actually becomes a sub 1. Visually, what is happening, so I'm going to draw it on my paper, but I'm going to have to erase it since I won't have enough space to solve. So you might want to, sketch this somewhere else, or maybe you're better at writing smaller than me. To give you a visual, here's your 25 degrees. So that is angle C. Remember, your 1 is little c, so it's always whoops, didn't mean to do that. It's always across from your angle, right? C is across from big C. And then A is, this is how I always draw it. You can draw it in different orientations, but it just makes it easier. Here's A. So those 3 things have to remain fixed. So what you found out is that C is either going to close here and create this 57.7 degree angle, or, give myself another color, I'm going to swing that gate in, and I'm going to get rid of this 25 just so I can see things. I'm going to swing that 1 in, and it can create this triangle. Now what happens here, just for you to buy into it, is, well, this red triangle now, that shaded red triangle, that's an isosceles triangle, since this is a 1 and this is a 1. Now remember, that red triangle is nothing to us. It's either that big triangle or the orange one. Well, if this is an isosceles triangle, that means that this angle here has to be 57.7 degrees, because across from the same length side are the same angles, like discussed in those special right triangles. So how could you figure out what this angle is? Well, this is a line. And what does a line measure? 180 degrees. So this angle is a linear pair. And that is how you find that second angle in the second obtuse triangle. So let me rephrase everything I just said. So I'm going to get rid of the visual. So visually, that's what's happening. Algebraically, what we're doing is, okay, when you get your first angle, okay, that's where the gate closes first, and then I swing the gate in, start finding your second angle, which would be its linear pair. So I'm going to go ahead, I'm going to save that value 180 minus the answer. So my second angle for A is 122.30 degrees. So that's in your obtuse triangle. So we have two triangles. We need to name them different. So that's why you want to make sure that you do A sub 1 and A sub 2. Because if you just have them A, then you can't have that because that means they're the same value. And now, so that's the hardest part, is just to get the ball rolling, is how to find the second angle. Now I'm going to continue solving for both triangles at the same time. That's personally how I like to do it. So if I wanted to solve for B sub 1, well, my triangle is 180 degrees minus the 25 I'm given minus the angle I found. Now realize your sub 1s are in a totally different triangle than your sub 2s. They're two separate triangles, so you can only combine everything in one triangle. So now I'm going to do my value of 180 for the entire triangle, take away 25, take away, and I thought I could go up there and grab it, but I do want to go up and grab it. Let's see. How do I do that? Oh, there we go. I can copy it and paste it. I'm on a tablet, so if you're on a computer, well, let's see. Copy. Oh, good times. I'm just going to type in as much as I can, and I'll get this to work better in our next video. 69728627. There's more values there, but I just want to get it as close as I can. So I end up getting 97.3 degrees. Okay, so we're still in the first triangle, and we have little a, little c, big A, big B, so we're missing little b. Set that up, again, using the full ratio that was given to you. Set it equal, I'm going to use approximately since I rounded that b, over little b sub 1. All right, going back to my Desmos. 2, 7, I didn't mean to erase that. Okay, so I get sine of the answer, sine of b, times 1, which we do not have to do. And then I want to divide it, so I should have done the division first. It's much easier, so I'm going to go back. Divide sine of my answer, close, times 1, divided by sine of 25 degrees. So I get 2.35. So let's see, we have a sub 1, b sub 1, little b sub 1. I'm done with my first triangle. Now to continue on with the second triangle, it's going to be the same process, except now we have to use this value because we're in the second triangle. All right, so let me get out of here. Let me just move this so I just have a better space for you all to see. All right, so I have, again, okay, so we're done with our first triangle. To find the other triangle, well, we know we have to find our angle B sub 2. We know our triangle is 180 degrees. We take away what was given to us. And we also take away the angle we found for A. So going back to Desmos, I set it up so my angle was in there, but remember, you can go up and grab it, or you can do answer. So 180 for the entire triangle. Take away what was given. Take away what you found, which, let me go ahead and put an answer. So my B sub 2 is 32.7. I'm going to just move this over a little bit. 32.7 degrees. Let's give ourselves another color. So we have A sub 2, B sub 2. These are fixed in both triangles. So I'm left with finding little b sub 1. So again, use the ratio that was given to you. Sine of 25 over 1 is equal to sine of 32.7 degrees, because that's your b sub 2, over little b sub 2. Cross multiply, so I'm skipping that step. Hopefully you're okay with that. And I'm going to go to my calculator, and it looks like it's, I'm going to do my division first. Sine of my answer times 1, not necessary, but just showing you the cross multiplication, divided by sine of 25. And I get 1.28. And there is my complete two triangles. So what I want to do actually is, again, just to reemphasize what in the world you just did, you do not have to, I'm going to just move to a blank space on our notes. So I'm just moving down to the last page. I just want to show you again what we did is we had this one big triangle. This was fixed to be 25. This was fixed to be 1. And I'm going off memory. I believe the other one was 2, yeah. And this was 2. So all of those sub 1s you found were, you found this guy, I guess I should label these. This is C, this is A, this is B. So you found this length, you found this angle. So this is A sub 1, this is B sub 1, this is B sub 1. And then what you had to do is you had to swing that one in. And so now this is A sub 2. This little angle is B sub 2. And this is fixed to be 1. And then this was your length B sub 2. Okay, so there's two triangles, and that's only because the corresponding side was less than the other side. And you were given the ambiguous case. If you are not given the ambiguous case, it's one triangle. Life is good. Okay, it's not nearly as much work. See you next time.